Hello everyone. In this question, we are asked to find the integral of sine to the power 3 by 2x plus cos to the power 3 by 2x upon the square root of the product of sine cube x times cos cube x times sine of x minus theta dx. Okay, so in this integral, we are given the variable is x and theta is a constant. Okay, we are given that this integral is equal to a constant a times square root of cos theta 10x minus sine theta plus another constant b times square root of cos theta minus sine theta cot x plus constant of integration capital C, and we are asked to find the product AB. Okay, so these two constants, so we need to solve this integral. So it looks very clumsy and it looks very difficult at the beginning. Okay, so let us start. So the numerator is sine to the power 3 upon 2 x plus cos to the power 3 upon 2x, right? And this is divided by the square root of sine cube x times cos cube x times, if we expand this sine x minus theta in terms of sine a minus b formula, okay, then we get sine a cos b, which is sine x cos theta minus cos x sine theta, right? I've just expanded this sine x minus theta here. Okay, now if I split these two into two different integrals, okay, then we have the first integral, which is basically I'm keeping this sine term in the numerator for the first integral. Okay, sine to the power 3 upon 2x, and I'm keeping the denominator as it is for the time being. Sine cube x cos cube x times this product sine x cos theta minus cos x sine theta, right? The entire thing is in the inside the square root. Dx plus integral of cos to the power 3 upon 2x dx upon the same denominator, sine cube x cos cube x times sine x cos theta minus cos x sine theta. Okay, so now you look in this right hand side that is given in the question. Okay, we are given square root of cos theta 10x minus sine theta for the first a, and for the second constant b, inside the square root it is cos theta minus sine theta cot x. Okay, so these are different. So what if for the first case, okay, for the first this integral, what if we rewrite this? I'm keeping sine cube x as it is times, what if I introduce another cos here? Okay, that is I am rewriting it as cos to the power 4x, and I'm going to divide this with a cos x. Okay, that is sine x cos theta minus cos x sine theta, whole thing divided upon by cos x. Okay, and the numerator is kept as it is. Okay, this is for the first integral. For the other integral, what if I introduce a sine extra here? Okay, sine to the power 4x, and this is cos cube x, right? Cos cube x. So I need to divide with a sine sin x later on. So I'm keeping it sin x cos theta minus cos x sin theta. Whole thing is divided by sin x. Okay, this is inside the square root. Okay, okay. So in the next step you will see why I did this. Okay, in the next step you will see, if I take these two terms outside the square root, okay, if I take them out of the square root, the first term will be sin to the power 3 upon 2x, and this cos to the power 4, this will become cos square x, right? And you see in the numerator we already have a sin to the power 3 upon 2x. Okay, so these two will cancel each other, and in the term remaining inside the square root in the denominator, we now have this becomes 10x cos theta minus cos theta, cos x and cos x will cancel each other, and this will become just sin theta. Okay, so this has simplified a bit. And similarly for the second integral, if we take these two terms outside this square root, this will change to sin square x times cos to the power 3 upon 2x, and we already have cos to the power 3 upon 2x in the numerator dx, and the term that is remaining inside the square root in the denominator, this sin x and sin x will cancel each other, so this becomes cos theta minus cos x sin theta. Not cos, this is cos x by sin x, right? So this will become, sorry, my mistake, this will become cos x upon sin x, so this will become cot x sin theta. I hope now it is correct, right? Okay, so you see this square root 10x cos theta minus sin theta, we have already got this, right? And similarly square root of cos theta minus sin theta cot x, we have also got this, right? So this has simplified a lot, and now we can cancel these two terms from either integral. Okay, so the integral now becomes, this is 1 upon cos square x, so this just becomes sec square x, sec square x, and this changes to 10x cos theta minus sin theta dx plus, this is 1 upon sin square x, right? So this becomes cos x square x, so cos x square x upon square root of cos theta minus sin theta. Is sin theta given before? Yes, sin theta cot x. Okay, so this becomes sin theta cot x dx. Okay, so we have simplified it a lot after doing a bit of algebraic manipulation. Okay, so now, sorry, now for this integral, if we use the substitution, we need this term, right? This 10x cos theta minus sin theta, this has to be present in the final answer, right? So what if we take u equal to this term 10x cos theta minus sin theta. Okay, similarly for this one, we do this v equal to square root of cos theta minus sin theta cot x under root. Okay, so on squaring both sides, we get u square will be equal to 10x cos theta minus sin theta. Similarly here, v square will be equal to cos theta minus sin theta cot x, right? So now on differentiating both sides with respect to x, okay, so theta is constant here, 2u du will be equal to sec square x times cos theta, and this sin theta minus sin theta is a constant, so this will become 0, right? Since it is with respect to x, it will be dx, and similarly in this side, this will be 2v dv. This cos theta is a constant, so this will go out. Okay, minus sin theta will be there as a constant, and derivative of cot x is minus cos x square x, right, dx. Okay, I hope everything is correct so far. Cos x square x sin theta dx. Okay, so now in the original integral, the term in the numerator for this integral was x square x dx. Okay, so let us isolate this x square x dx and keep it in one side. So we have 2u upon cos theta du is equal to sec square x dx, right? We have isolated this sec square x dx, and this denominator is our u. Okay, so this is for this first integral. Similarly here we have cos x square x dx in the numerator of the second integral, right? So the product becomes positive here, and we are keeping this cos x square x dx in one side. So we have 2v upon sin theta dv is equal to cos x square x dx, right? So now on substituting these two values of u and this 2u upon cos theta du, and similarly v and 2v sin theta dv in place of cos x square x in this integral, we now get from the original integral sec square x dx is nothing but twice u upon cos theta whole thing divided by u, just u, right, du plus the second integral cos x square x dx is nothing but 2v upon sin theta divided by v, right, just v dv. Okay, the variable is v in the second case. So this u and u cancels each other, so 2 sec theta comes out, right? 2 upon cos theta is 2 sec theta. These are constants, so this becomes 2, and integration of du will be just u, so this becomes 2u sec theta plus this becomes 2, this v and v cancels each other, 2 cosec theta, and integration of dv becomes just v, so 2v cosec theta plus c. Okay, so now we need to do the back substitution here for u and for v. Okay, so on doing that we get 2 sec theta times u was square root of 10x cos theta, 10x cos theta minus sin theta plus this is 2 cosec theta, I am keeping aside, 2 cosec theta times square root of what was v? V was square root of cos theta minus sin theta cot x, sin theta cot x. Okay, and then we have a plus c. So on comparing this with the original equation, it is a times square root of cos theta 10x, right? So a times square root of 10x cos theta, which is cos theta 10x minus sin theta. And for the second integral, this is b times square root of cos theta minus sin theta cot x. So this is b times square root of cos theta minus sin theta cot x. Okay, so we have finally got the answer. This is our a and this is our b. Okay, so we were asked to find the product ab, right? So this becomes 2 sec theta times 2 cosec theta, right? So this becomes 4 times sec theta is just cos theta here, and this is just sine theta here. Okay, so this becomes 4 upon cos theta sin theta. So if we multiply both numerator and denominator by 2, this becomes 8 upon 2 sin theta cos theta. Okay, so this becomes 8 by sine 2 theta, which you can also keep it here, or you can also rewrite it as 8 cosec 2 theta. Okay, 2 theta. So this is the required answer. I believe either this was the option or this was the option. I can't remember exact option, but there were options given. Okay, this was a MCQ, not a numerical answer type question. Okay, so this was a bit lengthy. While simplifying, you need to be careful while doing this simplification. Once you are able to do this is the key line here. Okay, this is the key line here. Once you are able to do this becomes like you get this format, right? You get this format of this answer here. Okay, once you get this format, the rest is just simple u substitution, v substitution. Okay, and this integral is up. Once you are able to get up to here, you can solve it very easily. The key step is this line. Okay, so do it very carefully, and I hope I was able to make you understand while doing this. Okay, I was very slow while doing this sum, so I hope you are able to understand it. Okay, so if there is any doubt in any of my steps, or you have any doubts uh, in this question, you can highlight in the comments. Okay, or if you believe there is any mistake, you can highlight in the comments, or you if you know alternative better solutions, faster methods, you can also highlight in the comments. Okay, so otherwise this is finished. This is the required answer, I believe. Either of these two, I can't remember the exact question. Okay, either this or this was the options given in the original question paper. Okay, so this is it. This is the required answer, and thank you for watching.